My next type of problem for this test is dividing rational expressions. Remember, rational expressions are expressions that have a numerator and denominator for polynomials, like these two right here. It's two rational expressions, and we're gonna divide them into each other. Now, when you divide two fractions like this, which a rational expression is basically a fraction. So when you divide two fractions like this, what you have to do is swap these two, swap these terms, and then multiply. So I had to swap these terms right here and then multiply. Now, I don't swap these first two. I always swap the second two, the two that I'm dividing by. So I swap the two terms and then multiply, right? So I'm going to go ahead and do that. And I'm going to write it down here. I got 9 over x minus 1 times, so I'm going to multiply, and it is x squared minus 5x plus 4 divided by 3x plus 3, like that. So now it has become a multiply rational expression, which is another type of problem you can get, but divide and multiply are almost the same, except that divide you have to swap it and multiply first. So now this is going to be a good example for dividing and multiplying rational expression, because divide just has that extra step in it. All right, the next thing is I need to factor all numerators and denominators. So I need to factor all the numerators and denominators, and let's see which ones factor out of this group. This 9 does not factor, so I just bring it down as 9 over, and x minus 1 doesn't factor either. There's nothing you can pull out of that term. Now these two both factor. This top one right here, I'm going to do a factor up here. I'm going to do an x method. Oops, that was kind of an ugly x right there. I'm going to factor what two numbers multiply to 4 and add to -5. That'd be -1 and -4. So this factors, this one right here, factors into x minus 1, x minus 4. So I'm going to replace that with that, x minus 1, x minus 4, and kind of rewrite it down here. And at the bottom, you got to notice things like this too. It happens all the time. It happened on review quite a few times. See that 3x plus 3 right there? They both divide by 3, so I need to divide them by 3 and pull that 3 to the outside. It's 3 times 3x divided by 3 is x. 3 divided by 3 is 1. So it is 3 times x plus 1, like that. All right? So now that I've done that, I need to set my restrictions. They might ask about restrictions here. Now this one's tricky. Like when you figure out the restrictions, there's actually 3 different places there could be restrictions on this one, because you divide by x minus 1, right? But you also divide by both of these because they're both dividing. So if either one becomes 0, it's going to end up being a restriction, because that can't happen. So my restrictions are that for this one, x cannot be -1. For that one, +1, my bad, x plus 1. X equals +1. So 1 minus 1 would give you 0. 4 minus 4 would give you 0. X cannot be 4. And also, x cannot be -1 right there. -1 plus 1 would give me 0. So x cannot be -1 as well. So those are restrictions. Just in case they ask for them, those are the restrictions that they can't be. Now, I'm going to go ahead and simplify now. I'm still simplifying. So I need to cross out anything that cancels. See these two x minus 1s? They cancel. And this 9 and 3 also cancel. They can both divide by 3, so the 9 becomes 3, the 3 becomes 1. So now let's go ahead and multiply these two terms by multiplying straight across with what I have left. 3 times x minus 4 is 3 times x minus 4. That's what I'm left with right here at the top, right? And then at the bottom, all that's left, this canceled, all that's left is x plus 1. So divided by x plus 1, and I would accept that as a correct answer because it doesn't factor any further. But you could also rewrite it as this by distributing both of them. I get 3x minus 12 over x plus 1, which would also count as a correct answer. So that is dividing rational expressions.